Hi, my name is Bob Zolo and I'm a product planner with Agilent Technologies. Today I'm going to demonstrate this product, the N6705B DC Power Analyzer, and the demonstration I'm going to do is I'm going to power up this cordless drill screwdriver using a 500 watt precision power supply module that we have installed in channel 1 of this 4-channel DC Power Analyzer. So let me begin by showing you that this drill screwdriver normally runs off of AA batteries. It's a little battery pack with 4 AA batteries. But for the purposes of this demo, we're going to power up the drill from the power supply, so we've got some test leads connected on the battery connections inside the screwdriver here. Now again, it should be a 6-volt drill screwdriver, but what's unique about it is because it runs off AA batteries, you figure, well, you wouldn't really need that much power to drive it. But we're going to use this 500 watt power supply because in fact it takes quite a bit of power when driving the motor inside this the screw gun. So let me get started by setting up the instrument. The first thing I want to do is set the voltage and the current to power up the screwdriver. So I'm going to go over here and set the voltage and the current. The voltage will be 6 volts because it's 4 AA batteries, so I enter 6. And now it's set to 6 volts. And as far as the current is concerned, I'm going to set it to the maximum, which is 50 amps on this high power precision module. So now I'm set to 6 volts and 50 amps. I'm going to turn the power supply on and now I'll have power available to the screwdriver. The power supply is on. You can see it says 6 volts, but there's almost no current flowing because I don't have the motor running in the screwdriver. And it's set in constant voltage mode. So let me begin by running the drill, the screwdriver here. So I'll just hold the button down, and as you can see on the display, it's pulling about 600 milliamps static current with no load on the motor. So that's what you'd expect, kind of low power, and as I mentioned, the power here is about 7 watts or so when the drill is running. Okay. But that's a static test. What I'd like to show you now is the dynamic currents associated with it. So with this instrument, not only can I see static, but I can put it in oscilloscope mode, and then you can see dynamics. So I'll flip it over to scope mode, and now I just have to make a few quick adjustments. So the first thing I'm going to do is I'm going to turn off the display of voltage because the voltage is going to be constant at 6 volts. It's not going to look very interesting. I'll go down to the current here, and it's set now to 50 milliamps per division, but I'm going to make that much higher because we're going to be pulling a lot more current than that. So let me go ahead and make that change by changing the amplitude here. We'll go to, well, let's go to 5 amps per division. I think that's fine. Let me slide it down on the screen here a little bit lower so that we'll have the full height of the screen to show it. Okay, the next thing I want to do is set the triggering. So I'll go to Properties, and it's right now it's set to trigger off voltage, but in fact what I really want to do is I want to trigger it off of a current. So let me set it to trigger off of the current on channel 1, and I'll set the triggering mode here to go to triggered mode, and let's just set the triggered current level to say 1 amp, and that will trigger on the positive rising edge of the current. Okay, go back to the scope and arm the scope, and now as I pull the trigger on the screwdriver, we should see a waveform up here. Yep, and there sure enough is that waveform, but let's move it over a little bit so we can see it a little more clearly. Let's do that. And okay, there we go. So if you look at the trace here, we have no current flowing when I didn't pull the button. I pull the button, we see a peak of current, and then it settles down. So let's make some measurements on this. I can put in marker mode, and now we have markers. And I'll move the marker over here to the peak, and I can read off the peak current is about 15 amps. So this set of small batteries would have given me 15 amps of startup current on the motor. And if I move the marker over here to the static level, you can see the current drops way down to about 1.3 amps. And in fact, if I let it go out a little further, you would see that static current of about a couple hundred milliamps, which is what we were observing in the meter mode before. So that's showing you that when you pull the trigger on this screwdriver, we get a real surge of current. The next thing that I want to demonstrate is a similar measurement, but this time I want to measure the stall current. And the way I'm going to do that is by changing the position on the head of this into manual. In manual mode, it locks the shaft of the screwdriver, and then if I try to actuate it by pulling the trigger, it's just going to grab the motor and stall. So I'm already set up to make the measurement. I just have to pull the trigger, and if I pull the trigger now, you can hear that the motor doesn't turn, but we're seeing a very different waveform. Here's that startup current. And now what's happening here is the motor is stalling, and the current shoots up, and then over here on the screen, what we're looking at is the protection feature of the motor drive circuit that says, you know, let's clamp that current so we don't burn anything out. And that current is clamping at 15 amps. So you can see quite a bit of current being pulled out of the battery pack under normal operating conditions when the motor stalls. So that's a quick look at how we could make this measurement using the power supply and the small screwdriver. Now I'd like to change the demonstration a little bit and show you the similar measurement, but this time on a much larger device. Here we're going to be using a 9.6 volt power drill. We've again taken the battery pack out and in its place connected the power supply to power up the drill directly. So this is a 9.6 volt drill and it will take quite a bit more power than the smaller drill screwdriver I showed you a moment ago. I've already got the whole setup preset to 9.6 volts, so I'm going to turn the power supply on and you can see 9.6 volts and again no current being drawn, and as I pull the trigger on the drill you can see now the current goes up. In this case the static unloaded current is about 2 amps. But what we want to see is that dynamic current. So let's flip over to scope mode. And I need to make one adjustment here. I've got it at 5 amps per division. We're going to need quite a bit more. So let me change the amps per division to say 20 amps per division. And I'll adjust it down a little lower on the screen. Rearm the scope. And now pull the trigger. And you can see now we have a peak current there. Let me zoom in a little bit so we can see that a little better. Zoom up. And if we put the markers on, now we make a marker measurement, and that peak current now on this one is about 33 amps. And if we look at power, which by the way is something you can do with this instrument, let me quickly show you how you would set that up. I move down to here and I turn the power trace on, and let me change the watts per division to say 200 watts per division. And now I can, let me get the markers out of the way. And now we have a power trace, which I will, if I get it on the screen here. Okay, and sure enough, there's the power trace. Let me get rid of the current trace so you can see the power. And the power trace, of course, looks an awful lot like the current trace because the voltage is static. But I can measure now directly off of the screen what the power is, and that peak power is about 378 watts. So here with the larger drill, we pull much more current, and we also pull much more wattage. So the advantage of using this instrument, as you can see, is it's one simple setup. We just have wiring into the power supply. We don't need the oscilloscope. We don't need a current probe. And we can also look at wide dynamic currents from a static current of some hundreds of milliamps for the screwdriver to several amps on the drill to a peak current of 10 times maybe the static current, all on one instrument without having to change setups. So that's a quick look at how the DC power analyzer can be used to measure motor current.